All right, so we're continuing our line class. I just kind of want to get you caught up. It has two private point fields. We had some issues with the constructors in that I didn't want, if a point changed in the client, to change the point in the line. So we had to adjust that a little bit. There was a bit of a workaround done where in the constructor we got the X and Y coordinates from each of the points and then set them in the line itself's points, but we first had to create those 2 points. So it started off by creating the line with the 2 points being at the origin, and then resetting the X and Y values for both those points. So we did that workaround. I don't know if it's the best workaround or not, but it worked and accomplished what we wanted to accomplish. So, you know, I might put that in the comments here somewhere where I say this is why we're doing that, but I'm not going to. I'll leave it. So we have two constructors, one that, actually now 3 constructors, one that sets it to the 2 values of the points, and then allows for those points to be changed in the client without changing them in the line. And then another one constructor that just with no parameters. It's I feel like maybe this should just be a private constructor because you don't really want the client to call this constructor that would have 2 points at the origin, and that would not be a line. So this constructor is just being used internally, so it would be just a private constructor. And then a constructor that creates a line that goes through the origin and the given point. Maybe I should say that here. Creates a line object that goes through the origin and given point. And this one is an internal constructor to create a line with both points at the origin. The internal constructor to create, let's call it a temporary line, because we're not keeping that line, we're resetting it right away above here in the constructor. Okay, so that kind of explained what's going on there. And then we had our getters for both points and setters for both points, so we can get the points out and we can set them. And now we're coming down to the methods. I think we also did a toString that just printed the 2 points out, and that was just to make my client run a little smoother. And if we look back at the client, you know, there's a lot of stuff that went on with the client where I've commented out a bunch of code so I could see what was happening more clearly. I got an extra space here. And what happened is we weren't marking what these things were. So like one thing you could do is, you know, when you print this line, you could put in a thing that says, you know, line 1. And then when you run it, you can kind of indicate what you're testing. And what I'm going to do is actually just delete all the other code now in the client, just because I don't need this anymore. What I wanted to make sure, what we fixed was that if you changed the point, one of the points that were in line 1, so here I changed P1, it did not change my original line, which is what's happening here, did not change. And then I set up a second line that went through the origin, and that worked. So everything to date so far is working. So I'm going to delete all of this stuff out of the client except the creation of the 2 points and the creation of the first line and the print statement for that line. So now I just have a simpler client, and I'll try to, as I add testing to the client, kind of include what I'm testing there so we know we are keeping track of what's going on better. Okay, so now we need findSlope. And so in the findSlope, we have to account for the case where the slope is undefined because you can't divide by 0. So I'm gonna use this double dot, not a number method to do that. And I also want to be able to sort of check those things. So what we're going to do, we're going to put it below our getters and setters, but above the toString method. We're going to go public. I'm going to use a capital double. So what this is it encases a primitive double, the primitive double, lowercase double, into an object, capital D double, that just has one field, and that's the double. But what it's going to allow me to do is use some of the capital double object methods, including, I can always just use this, but I want to be able to use it elsewhere as well. So this double.nan, I'll show you why I'm doing that in a minute. Okay, so this capital double is an object that contains a single lowercase double. It's called encasing. You're encasing the primitive into an object. So if I'm using this capital double, I can't use the equals equals. I would have to use probably the dot equals with the variables that get returned by this guy. Okay, so public double, findSlope, and it's going to have a parameter, no parameters, because the line is going to be like L1.findSlope, and we're going to return for a minute just 0.0. Okay, so returns the slope of the line. So I guess this is now returning a capital double through 2 points as a double. Okay. So when is the slope undefined? So if it's when the difference in x values is 0. So the slope is the change in y over the change in x. So that's, I'm going to write that as dy divided by dx. Maybe I put a little m here. That's kind of bad notation. That's the derivative dy dx. Here, the d is representing change in y over change in x. Maybe I don't need to tell you what slope is here. But I will tell you that unless the slope is undefined, in which case it'll return double NaN. Okay, so when is the slope undefined? When the difference in x values is 0. So in our case, we have to get those x values from those points. So if p1.get, let's do p2. So it'd be x2 minus x1. If p2.getx minus p1.getx is equal to 0, return double dot NaN. And if you think about why I'm trying to do this, so we say the slope is undefined when this happens, but I can't return a value of quote unquote undefined because that's a string. So I have to kind of make it a double somehow, and so that's why I'm using this double encasement object. Okay, otherwise, what we want to return is the change in y, which is going to be p2.getY minus p1.getY. The top of the slope. And then divided by, I've already calculated the difference in x, so I'll just copy that out. So I'm just going to copy this guy out of here. And then I need to make sure that the numerator and the denominator are both in parentheses. So parentheses pasted in there so that you're dividing. You know, to me, maybe this is a little bit convoluted, and you can see I have errors here. I don't see where it is. So that's, and also that's an integer. So now that I think about it, type mismatch cannot convert from integer to double. So then we would have to, let's see how to do this. We would have to double cast this somehow. Let's see if this works. No, what if I capital double it? Yeah, that's going to be integer division. So that's not what I want to do yet. So let's copy this first thing out. Let's have a double dy equals, there we go. So what that will do is convert that integer, the change in y values, to a double. And why don't we actually just, for both of these, let's just do double dx. It's just going to be a little clearer. Equals change in x values, and then below that I'll put the double dy equaling the change in y values. It's just going to make things clearer. And then when I do this test here, I can say if dx is 0, return double dot nan. Otherwise, return, delete all of this, dx dy divided by dx. And you can see that the logic of this is much easier to see what's going on. So even though this is a lowercase double, it's going to encapsulate it into an object and return it as an uppercase double. So it can do this from a double to a double. I know that sounds weird, but we're gonna test it right now, and I'm doing that mainly so that I can check whether or not something has undefined slope in the next part, is vertical or is horizontal. Okay, so we're gonna go back to our client, and we need to test our slope. So we can do a print statement. And I'm going to say, slope of line 1. And then, so this is kind of, rather than just printing the slope, I want to type out what I'm printing so that as I grow the client, I can see what's going on. We're going to find the slope here. So slope of line 1, then we're doing line 1 dot find slope. That's going to print out. Hopefully, let's see what the slope of that is. The change in y is going to be 10 minus 8 is 2 over 1. So the slope should be 2.0. Great. And now let's look at what happens if I change P2 so that it has undefined slope. So I want to do line 1 dot set P2. I can't do that yet until I set up the point. So let's do point P3 again. Or I can just do, yeah, let's do point P3 equals new point. So if I wanted a vertical line, the x values have to stay the same. So we'll go 5, 10. The y values can do anything they want, but if I go 5, 8, and 5, 10, that'll be a vertical line. And then set point 2 to equal P3. Okay, and then just to double check that that worked, we will copy this initial, so you can see, as you're testing things, your client grows quickly. So I'm going to say line 1, and I'm going to put here that it's vertical. So we've changed the x value, and we want to make sure that the second point changed. Let's check that. And so now I'm writing this in here so we can see that what I'm testing as I test it. And now we can see what the slope does now. And I might it just to make things a little bit clearer, you could put like a print line statement here in your client so that you can space things out a little bit so you can see better what's going on. And now, so now it returned this not a number for the slope of line 1. And so it's able to print that. I couldn't print, you know, this is a double. So, you know, I can't return the word undefined, but I can return this double.nan. And so now that we know that not a number. Okay. So the next two methods in our that we're after is a vertical line and is a horizontal line. And they're Booleans. So the vertical line will return true if the line is vertical, and that's going to happen when the dx is 0. And horizontal line is going to be true when the dy is 0. And as I'm writing that, I'm thinking to myself, well, we could just have a method that, you know, an internal method in our class that finds dx and finds dy. It's probably not really necessary. It's only one line of code, but you know, the slope is using dx and dy, and then these are using dx and dy. But it's one line of code, so I don't think it's a big deal to have it in there. It's kind of a nice. Might be a nice way to sort of see. How to do that, or we could just we could actually call findSlope. So we could say public Boolean. It's going to be isVertical. And it needs to return a Boolean. So we're going to return. So now this is why I had this be a capital double. I'm going to return findSlope dot is NaN. Maybe not. Oh, maybe I have to do this stuff. findSlope. Okay, so I had the syntax there a little bit wrong. I was typing that incorrectly. So I could use this. I don't need this keyword. I could use it or not use it here because it's gonna look for findSlope and it's gonna see the one above it. What I forgot was that when we call findSlope, we have to make it a function call by adding the set of parentheses. So that's the double, and I'm gonna use a method of that double object is NaN. So is it not a number? And now, so if it's not a number, that means it has undefined slope and it is a vertical line. So this will be true if it's not a number, and in which case it's a vertical line. So that's what we want. This will be false if it is a number, in which case it's not a vertical line. So that's what we want. And now we're going to go back to our client and test it. So that is not a number here. So I think we just need a print statement here. And I'm going to say it's vertical. Add to that line 1 dot is vertical. And I want to print it there, but I also want to print it above here. So I want to know, is it working when it's false, and is it working when it's true? So the first line is not vertical because it has a slope of 2. The second line has a slope of undefined, and it is a vertical line. So that is working. And notice by putting the prompts in for the testing in the client, by taking a little more time on the output, this has more meaning and it's easier to decipher what we're testing as we go. Okay, so now we have isVertical is done. Sometimes it's good, you know, if you have a long list of things that you're doing, you can kind of highlight them off when you're done with them. It doesn't mean they won't change as you go, but like it kind of can make it easier to see what's left to do. In your project, you have you're doing an object, and there might be lots of things, and so you don't have to tackle them all at once. You're tackling them one at a time, and you're using a client sort of intermittently, and then don't be afraid to kind of clear that client out, because as soon as it gets too convoluted, it becomes hard to sort of tell what's going on, sort of like we did in this video. So isHorizontal will be pretty quick. Public Boolean isHorizontal can also just call findSlope, and what we would want is we would want the slope to be 0. So we're going to return the comparison findSlope. I think we need to do dot equals, but let's test it. Equals 0. So notice it doesn't like this because, oh, I need the parentheses. That might be why it doesn't like it. So even though findSlope is a capital double, it is still allowing it for me to compare it to a primitive double, lowercase double versus uppercase double. So where this was nice was where I used the capital double was right here. If this were a lowercase double, watch what happens. If I use lowercase double there, this is okay, but this is no longer okay because I don't have a method attached to a lowercase double. So I can't use this is not a number here. And then, what do? You just test it's, how do you test that? So because we're returning this thing that's an encapsulated double, we want that to be the object double. But down here, it's okay to go the other way. So it's okay to take the object of a double and compare it to a primitive double. All right, so we're going to run our client, and I guess we'll go right below here, and we'll go system.out.println. I want to check isHorizontal. Line 1 dot isHorizontal. This one should be false. If we did it with the next line, it would also be false. Oh, error, cancel. Typo. So we know it works when it's not a horizontal line. We should check it if it works when it is a horizontal line. So just debating if I should start a new line, or we've checked that this works for the vertical line. So we could change this code here to check if this works for a horizontal line. And what would make a horizontal line would be that so our original point 1 was 5.8. To make a horizontal line, you would want the y values not to change. So we might say 6, 8. And then I'm making that my second point. This is line 1. Is it horizontal? Slope of line 1 should be 0. And I could just change this to is horizontal. Since I've already checked the vertical stuff, I don't need to keep that in my client. And in fact, it makes the client get too convoluted. So really, I could also get rid of this isVertical. I've already tested that. I don't need it anymore in my client. But it doesn't hurt to leave it there, because you can kind of see it's not vertical, it's not horizontal. This one is horizontal. Perfect. So we're going to end this video. We'll come back. I'm going to go back to my line code for a minute. Just recap. Video 1, we made our constructors. There's 3 of them now. You can pause if you need them. Video 2, the getters and the setters, and we also did the toString method which is not displayed here. This third video, findSlope, and the two Booleans, isVertical and isHorizontal. And you can see, you know, these codes are getting longer and longer as class. There's lots of little methods in here. So none of the individual methods are that challenging and tasking, but as you start to build them on, we want to be careful and make sure that everything is still kind of working as expected. So that's where the importance of the client comes in, and also just sort of, you don't want to write everything and then try to see if it all fits together. You really want to do things one method at a time. And then revise as needed. So like when I went back and changed my constructors, it was a little confusing, I'm sure, but it's important to kind of recognize when something isn't working or at least not working how I anticipated. So it's not what I wanted. So I worked a way to fix that, and then it kind of protects the class itself a little better. Okay, we'll come back for another video in a minute.